Hello, everyone, and thank you for joining us for today's webinar, Empowering Fieldwork, Routing Optimization, Geofencing, and IoT in Dynamics 365 Field Service. My name is Mackenzie Lout, and I'm on the marketing team here at Velosio. I wanted to welcome you and kick off today's events with a few housekeeping items. Everyone is currently muted, but we want this to be as interactive as possible, and we want to answer any questions that you may have today. So go ahead and enter your questions in the questions pane, and I'll pass them over to our presenters at the end of the session. This session is being recorded, and you'll receive a copy of the recording along with other resources following today's event. Again, thanks for joining us, and with that, I'll go ahead and pass it over to our presenters, Dave and Bill. Okay, 1 second. Let's see.
Thank you, Mackenzie. I can go
Here
ahead
we
and
go.
start talking while we wait for that.
Okay.
It wasn't allowing me to share my screen, but let's get this thing started.
Should be good now.
Finding it. For some reason, it's not looking for. Okay, I should be able to share it now.
Perfect.
Should be
There
able
we
to
go.
see it. Nice. So we'll put this in. All right, everybody should be able to see my screen now.
All good.
Okay. All right, good. Well, thank you, Mackenzie, for that intro. Yeah, we're looking forward to talking about this. So what we'll do is go through this agenda real quick. This is a second part of a series. So if you didn't join us in the first one, it'd be good just to refresh yourself and watch the first part of the series. This part is going to kind of enhance on some of the items that we talked about in the first one, and add a couple more talking points as well. So what we're going to do for the agenda, we're going to go through an introduction of myself and Bill, then go through some discussion points, customer story with the problem statement, customer story with the solution, and then the customer story with the outcomes. And that will tee off. I'll set up the ball on the tee for Bill to take over and show you some of these features with the out-of-the-box Microsoft Dynamics 365. So I just want to start off by putting this on the screen first. This is a poll. It's just going to ask, what are your biggest challenges in managing resource scheduling? Is it improving resource utilization rates, real-time visibility of job status, visibility into current resource location, meeting service level agreement compliance, or optimizing resource schedules? So, introduction. My name is Dave Sigler. I'm from Velosio. I'm the field service practice lead for Velosio. I've been in the Microsoft space for a little over 8 years now, but my main background is field service. I was in the field service industry for over 26 years. Bill?
Hi, my name is Bill Malone. I work for Microsoft. I'm a Dynamics technical specialist. I've been in the Dynamics space for well over 10 years, kind of interspersed in my career here at Microsoft, but I've worked with Dynamics from version 1.0, 1.2.
Thanks, Bill.
Mhm.
So as mentioned, some of the discussion points here, this is just a map that is pulled off of Google, but this is kind of a concept that a lot of companies have where they have multiple clients located in different locations and having the need to send texts or other resources to those locations. So what we're going to talk about is how to optimize the field processes with Dynamics 365. So this customer story, this is a real live customer story that we had a client reach out to us, um, and they came with us with a few problems, and I'm going to talk through some of these here. So one of those was real time updates of their resources. So that's having visibility into the resources and updating their work orders when they were on site, from the time they arrived, what was happening while they were on site, and then when they left the site. Um, their process was the tech would show up on site, complete the work, move on to the next site or whatever was on their schedule, and then they would updo their paperwork at the end of the night. Uh, Next item was tech utilization. They had poor workload distribution. They had techs that were working 125, 150% utilization, and they had techs that were sitting on the bench, or even some that were working like maybe 40%. So their average utilization was at 72%. Dispatching, they had no visibility into their tech's current location. So they didn't know if they had a failure, if they had a tech within the area that can go to that site or not. And another difficult aspect of their work stream is their techs were assigned to routes, and those routes were 3 stores that were dedicated to the tech, um, 3 to 5, and they had techs that were located close to those sites, within 5 miles, but because they weren't assigned to that territory and that site, there were failures happening 5 miles away from them, and those techs could not be dispatched because they weren't in alignment. So that had a impact on their SLAs. And when we talk about SLAs, those are your service level agreements, which are how you rate your response. And sometimes it's compliance on contracts, on how you meet metrics for your clients. And the particular one we're talking about here with the service level agreement is their repair SLA, which is um, going from creation of the work order to completion of the work order, and the failures is fixed. Um, the next thing they had an issue was their asset failure logging. All their failures were reactive. The system went down, the customer would pick up the phone or send an email and say, "We've got a problem. Can you send a tech on site?" And the last thing I want to talk about is the response SLA. So because of that issue that I talked about earlier, where techs were, even though they were close to the locations, they weren't within that same region, and they had dedicated dedicated tech for 5 locations. They had an issue where they couldn't get to those sites that quickly because the as you go back and look at the utilization, as I mentioned earlier, they had some techs that were being utilized 125, 150% of their time. So those other techs that were sitting there that were on the bench or sitting there at less than 50%, they weren't dispatched because of the structure they built around their territories. So what did we do about this? So once we understood their problem, we went in utilizing Dynamics 365 and the native functionality. For the real-time updates, what we did was added a mobile app, and on that mobile app, it has geolocation. So when a tech is moving or going from site to site, it's being updated real time, and as close to real time. It's not perfectly real time, but as close to real time as possible, so that dispatchers can actually see on a map, actually see where their resources are located at a current time. Um, Tech utilization, what we ended up doing was kind of time box their work hours. So within Dynamics, you have a way to add work hours to a tech. So they started at 7, ended at 8, and that's what we ended up doing, was kind of time boxed them. Dispatching, we added regional territories. So by doing that, what we ended up doing was, instead of that one tech covering those 5 locations, now you had a pool of techs that can cover not only those 5 locations, but hundreds of locations within that territory. So what that ends up doing is allowing dispatchers, and as I mentioned, I'll talk about in the last point here, is actually have auto scheduling go and find the closest, most available, and the proper skill set to send to that site. Um, Added IoT. So IoT, that's the Internet of Things. So this is a way to not only be moved from going from reactive um, state, but it's allowing you to become more of a proactive. So when the system or the asset uh, logs a failure, what it will do is actually create a work order so that it's in the queue and your dispatchers can dispatch somebody before the customer even knows about it. And we'll talk about a piece, I know Bill will talk about it later in the demo, but it also enhances your predictive maintenance as well. So this is where you can start watching the logs of different gauges or different measurements on those assets, and you can start predicting when you need to replace parts before they actually go to failure. And then the last piece was response SLA compliance. So what we ended up doing was created configured resource scheduling optimization. So what that is it's an add-on for Dynamics, which is a Dynamics tool, and it actually takes the schedule and optimizes those routes for those techs. So it's going to find the right skill set, the closest tech, and it's going to send them on site. And then we also did geofencing, which geofencing, what it does, it builds a perimeter, a latitude longitude perimeter around a site. And what we ended up doing was with that geolocation from the mobile, when a tech actually showed up within that perimeter, it would actually we configured automation in the background to automatically change their status to in progress. So what that ended up doing was showed that your response time was met because that didn't require a tech to actually physically go in and change that status. It automatically did that. And then when on the flip side, when they completed the job, when they left the site, if they forgot to change it to a complete status, we had an automation that would, as soon as they left that perimeter, it would flip the switch and change that work order to completed, which then stopped the clock on your repair SLA. So what I wanted to do here is kind of just show you a kind of a high level view of what resource scheduling optimization does. As you see on this left panel here, this was not an optimized schedule. This resource, if you see down here at the bottom, they only had 5 work orders. And as you look here, you can see the route that it took. So this resource started here, went up to this location, then went to this location, then went to this location, then went to this location. So as you see, they were all over the map. When optimization ran, what it did was it decreased the drive time, decreased the expenses and everything, and increased your utilization for that resource. As you see on this right pane, it actually created a cleaner route for this tech. And also by doing that, it added 2 more work orders to their day. So now your utilization rates go up. Right. So what were some of those outcomes from doing this? So the real-time updates, now from org level, there's full visibility in the current status of the work orders. So they know what work orders are being worked on, which ones are completed, what's the current status of a work order, especially these high priority ones. And then also the ability to trigger response SLAs automatically. And what I'm talking about there is what we talked about with the geofencing and that automation that when they entered that geofence, it automatically changed their status to in progress. Next thing was the tech utilization. So as you saw from that resource optimization, and by creating those territories, those regional territories, and getting away from this 5 store per tech um, territory into more of a regionalized territory, it improved their utilization to 90% for their techs. Dispatching, it gave them a map with tech location and work order routes so they can see real time where their techs are and see what their current day consists of. And that improved their SLA by their repair SLA because now you're optimizing your routes, you're optimizing who can get there faster and repair these items, and it increased their repair SLA to 96%. Their asset failure logging, as I mentioned earlier, once IoT was turned on, that's going to allow you to go from a reactive to a proactive response, so that you can the client was able to go in and they were able to arrive on site before the customer even knew there was a problem. And again, as I mentioned with the predictive maintenance, that just allowed them to repair items before they hit failure. And then the response SLA, of course, this all these combined helped improve the response SLA, and their compliance rate went up to 95%. And with that, I'm going to kick off to Bill, and he's going to show you all the nice little tools and give you a little insight into Dynamics 365.
Thanks, David.
Welcome.
Got to figure out which screen to share. I think it's this one. First, you should see a Dynamics dispatch board. Does that popping through?
That's there.
All right, cool. I just want to do a little recap for the benefit of those who weren't in the first session, but also kind of a transitionary discussion for those who were. At the end of the day, this slide shows you what field service management is all about. It's about getting the right person who has the right skills and certifications, perhaps, at the job site at the right time for the customer with the right equipment. And that equipment might be tooling, that equipment might be inventory in the form of spare or replacement parts. The flow of this part of the presentation is to kind of recap what it looks like to schedule and complete work in Dynamics. And then we'll talk a little bit deeper about schedule optimization, the concept of IoT monitoring of assets, and then the benefits of turning on geofencing in Dynamics for your mobile technicians. At the end of the day, there's a dramatic evolution in the service business that moves from, maybe 10 years ago, we had completely reactive service. Something broke, we got a call, we went and fixed it, to now proactive and predictive and preemptive service. And it's all about not only managing work orders and getting those scheduled appropriately, but remotely managing assets, sensors on assets feeding you data. That data obviously would denote an outage and where you have to go fix it. But we can also, with data over time, begin to predict failure. And that's where it really gets interesting and revolutionary for customers. In the first session, we reviewed how work orders can be created. So the various scenarios in Dynamics where a work order needs to happen. And what that means is we have to roll a truck with technicians in order to do work. And it could be anything from repairs to installations to deliveries or whatever. When you have to roll a truck, this might be the way to manage it. In a sales scenario, for example, I might sell a product and that product needs to be installed. So I generate a work order to get the installation crew out there. Obviously, customer support scenarios, kind of traditional reactive support where an issue's occurred, the customer noticed it, they call us, and we have to roll a truck. A work order gets generated. And now, today we're going to talk a little bit more about this area, IoT and connected field service, where we have sensors on assets monitoring the performance of the assets or its components and beginning to predict when that might fail. And certainly, where required, denoting an outage. We talked in the first session a little bit about preventive maintenance. So how do we schedule preventive maintenance over a quarterly, yearly, or what have you, whatever time frame basis? and not only get the resources there and get the work order scheduled, but also apply the appropriate billing in the form of recurrent invoices. And then finally, this is kind of a COVID scenario is what I call it. During the COVID timeframe, we were so limited in face-to-face contact that oftentimes field technicians who are out there fixing things became the only face of your business to the customer. And so there are opportunities in those kinds of scenarios to provide the tech through the mobile experience, opportunities to cross-sell or upsell, and increase the value of that customer over its life cycle with you. As I said in the first session, we covered these two scenarios, sort of reactive support, and then a little bit about asset management from the perspective of preventive or recurrent maintenance. In this session, we'll focus a little bit more on the IoT experience, but ultimately, each of those scenarios leads to a work order. The work order can consume product from inventory, thus an impact on supply chain. And of course, we have to bill for the work done and the inventory consumed, and oftentimes send out a survey experience for the customer to tell us how well we did with that work order engagement. All of these can be handled within the Microsoft Cloud. So let me just step out for a second now and kind of in review, talk a little bit about getting work done. If you look at my schedule board on the screen now, I have lists of unscheduled work orders down here in the bottom, and up here on the schedule board, you can see the set of work orders that I have booked already for my techs who are out in the field. And we talked about the fact that there are 3 ways to schedule. I can drag and drop this work order out on the board and put it in an available swim lane. I can select a work order and use a wizard-based format to find availability to get the right tech with capacity close to the work order involved in that work. And then the other one is RSO. Before I get to RSO, let me just kind of complete the recap scenario when we schedule work. So I'll manually schedule this one. I'm going to drop it on the swim lane for the user Bill Malone. And as that's landing, I'll point out a couple things. There are different statuses indicated on these little tiles that represent work orders in each swim line. One of them is a priority indicator. The other one is, a time status indicator. So notice work order 54, that time status indicator indicates that work is in progress. The technician's working on it. That clock indicates that the work is scheduled. So not there yet, not working on it. So we're going to talk a little bit more about that when we talk about geofencing. But if I quickly flip over to the mobile app and I look at the mobile app experience, I have now work orders on that mobile app. If I select one, as we saw in the first session, if you were there, this tells me, it provides me all the tools I need to monitor the time status, indicate that I'm working or on break or traveling. And we can automate that with geofencing and a little bit of a flow in order to adjust the status. But maybe most importantly, the mobile app tells me the exact list of service tasks I need to execute. It provides me with a list of common spare parts that might be required in a job like this. Even gives me documentation. So I have a spec sheet for the generator that I'm working on right there included with my booking. So all the details I need in order to complete this work. And as I finish things, I simply check them off. As I consume inventory, I indicate that I used it. And then finally, when you get to the end of the work, I can indicate that I've completed it. I can take notes about the work, including photos or video. Oftentimes our customers have to take pictures of completed work or even take a video of the facility within which they were working. Capture signature that the work was completed, and finish the work order. So let me flip back here, back to my dispatch board. That was a very quick recap of the flow of work. And remember, a number of ways that a work order can land, meaning a customer could call in, I could get a chat from my customer portal, I could get an indication of failure from a sensor on a device, or preferably pending failure so I can preempt an outage. David also mentioned the benefits of sort of changing the way technicians behaved. And that means initially they went from store to store, 5 of which they were assigned. And it really didn't take into account what technician lived closest to those stores, or as you saw in David's slide, didn't take into account the routing that was most efficient for those stores. Another thing that was important was for that customer to be able to break out regionally. And I'm not going to go too far down this path, but on the schedule board, this is kind of the default view, all of my technicians, but I can create additional schedule board views. And I can center that view or narrow down that view based on technicians within a particular sales area or whatever other area denotation that you might have. That means maybe it's within a zip code or within a particular neighborhood, within a certain number of miles of a central location, whatever it might be. I can configure technicians to be territorialized like that. And then I can create the proper schedule board views so I can view the technicians territory by territory, or perhaps team by team. And that makes it pretty straightforward to be able to manage by region. If I take that one step further, I'm going to just show you a couple of other examples. Here's a schedule board similar to mine, but with more regions on it. There's the initial public view. And then there's Tampa 1 and Tampa 2. There's a project group, all of Florida. Whatever you might need in terms of grouping the visuals and the teams such that you can manage them appropriately. Here's another interesting customer example. If you notice the swim lanes over here on the left, they're not people, they're not technicians, but rather shop locations. So this customer was booking the shop location as a critical resource, and then a crew worked within each shop location. And so they scheduled on that basis. My point in showing you that is just to show you that it's highly configurable. And then finally, David mentioned that for this customer, they applied resource schedule optimization. And resource schedule optimization is sort of this black box tool that allows you to schedule by adding data in the form of resources and capabilities along with constraints for which you'd like to optimize. A key one in our customer example here was to optimize routing as well as do some work with territories, such that we got the technicians off of being just mapped to a handful of stores. We're optimizing now around the work and the schedule, the technicians' capabilities and their availability and their proximity. Each of those dimensions can be addressed with resource schedule optimization. It's basically a process of data in, locations, territories, skills, restrictions, restricted data points like restrictions for high priority customers, even down to setting a technician as the only technician, the preferred technician and only technician for a particular customer. And then the constraints, the things that we're trying to optimize for, oftentimes travel time and minimizing costs like fuel consumption are high priority. But I can enter these data points and constraints into resource schedule optimization, and resource schedule optimization will present me with a possible schedule or a couple schedule views, the ability to kind of iterate to create different views or different versions of the schedule such that I can pick the one that's just right. Now, if you think back to David's slide where The important things to notice here, I mean, this is huge. But if you look at the number of work orders here and compare that to the number of work orders here, seems pretty, I don't know, minute, 5 work orders to 7 work orders. But sometimes it's interesting to take a look at the math. And this isn't hard to do. Let's just say that that customer had 20 technicians, and we know that they did 5 work orders a day. I've just plugged in some numbers here, and I suggest that the average work order duration is 90 minutes, and they bill at $100 an hour. So each work order, $150. Well, if I can bump from 5 work orders a day, which generates a return of 3.6 million annually, to 7 work orders a day, because I've now optimized the schedule based on the constraints that are most important to me and my customers. Well, now I'm generating 5.0 million a day, an increase of 1.4. And there are lots of considerations to think about. This is just strictly back of the napkin math with a crayon that says, God, if I can add two work orders per person, I can generate a pretty substantial increase in the bottom line. And there are other assumptions here, 20 work orders in a month, 20 work days in a month. So maybe, I'm not sure if that's conservative or not. It really depends upon your business, but that's what I made in terms of an assumption. But you can see the pattern here. I can do some pretty simple math to figure out there's tremendous returns to be had if I can do something as simple as add a work order or 2 per technician per day. Okay, let me get that off the schedule. A couple more things to consider. When we're looking at a work order, again, this is a bit of review from the previous session, so forgive me if you were there. But when you talk about getting the right person with the skills and certifications and the inventory and the job instructions in the hands of the technician, here's where it all comes together. The work order pulls together the booking, which is the time slice on the calendar that maps that technician to the customer and the job. The incident type is the definition of that job type itself. So this one is general generator PM. Let's take a look at what that brings to bear. Here's the incident type record in Dynamics, and just really quickly, you'll see that here I define the service tasks that have to happen. I give them an estimated duration, and I can even tie in inspections. So I can use inspection templates if necessary to provide a checklist at the end of a job task. Or maybe doing an inspection is the job, and I might have a much more involved inspection sheet tied to the incident type, thus the work order. So the step-by-steps, the inspections if required. We also map in the products that may be consumed in that type of a repair. So an oil filter cartridge, a fuel filter, oil itself. And then finally, the characteristics or skills that would be required for the technician that's on the job. If I need to define skills and certifications that are going to be required, sometimes if you go into high security areas, clearances are a characteristic. All those things can be defined so we get the right technician with the right skills. Another concept we talked about, and I mentioned just briefly in the slideware, was the notion of recurring work. That's where we set up an agreement with the customer. An agreement has a time frame, a start and end date. It's like a contract. And it defines the bookings that are set up. So if I look at this monthly maintenance booking setup, you'll see that that generates the work orders every month on the required date within the required parameters, meaning flexibility around a preferred start time, and the right work order type and incident type. Similarly, invoice setup. We look at invoice setup. This is just setting up the recurring billing that happens month to month as the work orders are completed. So that's how we kind of handle the preventive maintenance cycles within our business. We set up the agreement to generate the recurrent work orders. Those work orders land on the schedule board in the time frame that we defined, sometimes the week before, sometimes a month before, depends on the needs of your business and how far out you have to book, and then bills for it accordingly. All right. Moving back to the schedule board. I want to take a look at a couple more slides here. And let's hone in on this IoT connected field service experience and what that looks like. First, excuse me, this is sort of progression of the state of maintenance models. And it starts over here on the left where we have traditional break fix. Then preventive maintenance is kind of a second level of work provided. And this is kind of the current state for most of the customers that we talk to about field service. And they're evolving to levels 3, 4, and 5 from conditional maintenance all the way up to intelligent operations where autonomous actions are taken on assets to ensure maximum efficiency, maximum utilization, and minimum downtime. There's an evolution that this solution can take you through as a business in order to get to the most optimal level of service performance. Now, if we move back here for a second, remember that we talked about the customer assets and the fact that that diesel generator that I was just scheduling and then we looked at in the mobile app is an asset that belongs to my customer called Fourth Coffee. It's based on a product SKU that we sold them. And here I'm monitoring the complete history of this device, including the work that's been done over time. If that device had sub-assets, they'd be indicated here. So a hierarchy of the asset and its sub-assets. And then down here, this area of connected devices. Let's dig into that a little bit further. This is where IoT comes into play. And in essence, you'll see a few things. There's some linkage up here on an asset to register devices, connect them, pull data, and even verify IoT setup. What I'm showing you here is the linkage, the fact that field service is ready to connect to Azure IoT services and start pulling in device data from sensors out there on the assets. And then the end game is that we begin this whole evolution to preventive maintenance that's predictive. So if I look at a couple of examples, here's a customer asset, which is a solar panel, and just an interesting view of an IoT connected asset. Looks a little different than the asset record I just showed you, but I just showed you the out-of-the-box form. This is one that's configured for a specific customer. And you can see that via sensors on the asset, they're monitoring asset health. They're looking at diagnostic messages and tracking asset telemetry over time. Pretty interesting stuff. This is a view of an IoT alert itself. So when an IoT alert is triggered, what that means is a sensor tripped a specific threshold that we've defined and sent us an alert to let us know what's happening. And so in ongoing monitoring, of course, you can monitor the performance over time, the number of times it violates thresholds either up and down, depending on the asset. And then, of course, understand when there's an issue that requires somebody to get over there and work on that device. Excuse me, time to take a drink of water. So another couple of examples. We look at this IoT data on a asset by asset basis, but we can also monitor on a kind of the entirety list of IoT alerts that are coming in, essentially the data flow of alerts. And remember, these are just the alerts when they've crossed a particular threshold. And it's a configured notification that we have defined in the system in order to let us know what's going on. And we can take that all the way to the point of a digital twin sort of environment where it's applicable. So if you look at this view, there's a digital twin, and you can see that there are various sensors being monitored across this set of rooms on assets, and it's letting me know metrics across those assets, and also when various components have reached critical warning stage or state. We're even monitoring whether or not a piece of technology needs to be updated from a software perspective. All this capability is available through a combination of field service and Azure IoT services. And of course, Microsoft has a first party linkage between them. So it's not like you have to do a bunch of work to connect things up. They're designed to work together out of the box by the same vendor. And that's important because taking away the linkage that has to happen or the integrations that have to happen across different vendor solutions can be a dramatic savings, both in cost in order to get it done initially, but then in lifetime cost over the maintenance of that connection or integration. So that becomes important. Okay, let's move on to IoT and wrap this up real quickly. David did a good job of explaining IoT, geofencing. David did a pretty good job of explaining what geofencing is. I'm just going to recap that here. It's a feature that allows you to draw a virtual perimeter around a location. So in essence, we track service locations based on latitude and longitude, and we can draw a geofence perimeter of a certain distance or threshold around that. So you create a geofence around a service account location and then compare the location of the field tech via the mobile app to that location. So we're measuring two things there. Once the tech crosses the geofence, that's when the customer, in this case, automatically had their status turn from traveling to in progress. When you exit the geofence, meaning that the technician leaves that work location, another geofence event is created then, and we can spin logic off of that. So in the case of this customer, we marked the work complete after leaving the geofenced area. And then we can do other things, not only locate the technician, as you see here, where let me pop my slide up again, where the technician located down here in the map has entered a geofence. And I can see by clicking that work order, the map location to highlight Abraham in this case. That geofencing creates geofence events. And you can look at this list where Abraham entered the geofence at HQ San Fran headquarters, exited the geofence, etc. So marking those events removes a step for the technician of having to set the status on their own in the work order. So this eliminated missing data, and it also eliminated those scenarios where we don't have the front end of the time block because the technician forgot to mark as in progress, or we have a huge time block because the technician forgot to complete the work order. So that's the status setting scenario with this customer. You can also do other things with geofencing. You can extend that capability and do things like send notification emails or SMS texts by tracking the technician's proximity to a geofenced service location, I can now set notifications to go out to customers 15 minutes ahead of the technician's arrival. Or if a technician gets delayed in traffic and there's an obvious slowdown, logic that evaluates that and says this technician is going to be late. And finally, we can wrap all this up with a set of out-of-the-box reports that allow you to monitor around the important issues for this customer and many customers, but analyzing performance across territories or resource and utilization performance, or really any other dimension that you can kind of think of around managing a field service operations or a plant service operations. Reporting comes in the form of work order summary reports. So we can pull it together, kind of centered around summarizing work performance, trends by status and substatus, trends by that primary incident type that we looked at, mean time to complete, broken promises or broken SLAs, all those dimensions are considered. So with that, I'll end my portion of the session. My goal there was to recap kind of the flow of work, and then the key records that we looked at last time, we showed you again this time, the incident type, which pulls all the right things together, scheduling of preventive maintenance, preemptive work in the form of agreements to schedule recurring work orders and recurring billing associated with that work. And then finally, we took a little bit deeper look into the notion of what IoT brings to the table, and also the capability around geofencing, all with the goal in mind of optimizing and moving you sort of up the chain in those stages of maintenance level, from the usual and current state that we're used to state 5, a cognitive state, where at the same time, you're increasing asset uptime, you're also increasing revenue and reducing costs. Okay, with that, I'll turn it back to you for closing.
Great.
Awesome.
We will open the floor for any questions. And it looks like a few have already been sent in. So we'll start off with, okay, when using the resource schedule optimization, are you able to drive optimization by priority of the work orders?
I can take that one, David.
Okay, sure, go for it.
Yeah, work order priority. Can you hear me okay?
Yep.
Yeah. Work order priority is often a driver, one of the drivers in resource schedule optimization. So absolutely, that's usually one of the criteria. Another one that's really common is organizations will sometimes classify their customers, on a simple level, gold, silver, bronze, perhaps, or maybe different levels of maintenance agreements that include different service level agreements. And so we have to consider that in RSO. And then, you think of things like hard outages. There's often a hard down, system stop category, or categories like that, or varying levels of that, which also need to be prioritized on the schedule board. Those are all kinds of constraints that might be considered, along with what we talked about a lot in this customer example, trying to optimize routes, thus save fuel and time.
Yeah, that's great. Hey, I just want to add on to that as well, Bill. So the thing about resource scheduling optimization, you could set the frequency that you want it to run. So if you have like lower priority work orders, you can have it run on a nightly basis or every 6 hours. And then of course you can have them drive, if you have high priority work orders created, that it would drive every 30 minutes. So there's different levels you can drive the algorithm to run.
Yeah, I hate to keep adding on. Customers will usually schedule RSO to run perhaps nightly or weekly. And then some event might come up where they have to get a work order on the schedule, so they can, run an unscheduled run of RSO to optimize for that
Mhm.
outage or event that happened.
Yeah, it's a great tool.
We don't demo it, just for your information. We don't demo it because it's kind of a black box. It doesn't demo real well. You configure the things for which you're trying to optimize, run the optimization schedule. It pops you an opportunity. So doesn't really show a fantastic demo.
Yeah.
Okay,
Yeah.
great. One more question, it looks like. Okay. Can dispatchers make adjustments to the schedule after resource schedule optimization runs?
I can go ahead and take this one, Bill.
But
Yes. So yes, once resource schedule optimization makes their run and it creates the schedule, dispatchers can move things around on the schedule, even though it was scheduled by resource. I'll just say RSO instead of saying the whole name again. So when RSO runs, yes, you can definitely a dispatcher can go in and adjust the schedule.
you know, add on to that, you can run RSO, and that doesn't necessarily mean you're applying the schedule. So if I have an event come up and I want to optimize around it, I can do a run of RSO. It'll present me options, and when I see one that I like, I can apply that option to the schedule board, and that's when it lands on the actual schedule and goes out to the technicians.
That is correct.
Okay, great. I think that is it then. Thanks, Bill, and thanks, Dave, and thanks everyone for joining us. We do have one more webinar in the series coming up here on November 1st. So that'll be covering inventory and asset management with Dynamics 365 Field Service. And if you want to join us for that, I'll be sending out more information, including this recording and links to sign up for that one. With that, have a great rest of your day, and we hope to see you in the next one.
Thank you.
Thank you very
Bye.
much.